Okay, this is part 4 of the screencast regarding this PowerPoint presentation on life in the universe. So I mentioned in part 3 of this screencast that when we look out into the universe, when we look out into the galaxy, it appears to be pristine. We don't see any evidence, for example, of any sort of advanced alien civilization out there. Okay, now let me elaborate further on some of the ideas associated with this. Okay, let me go ahead and start this. There we go. Okay, so for example, we can imagine vast engineering projects such as ring worlds. A ring world would be a ribbon of material that circles a star. Those of you that are familiar, for example, with the video game series Halo have encountered this within the game. The Halo itself is actually an example of an idea called a ring world. We could also imagine such structures as what are called Dyson spheres. A Dyson sphere would be a construction around a star, say perhaps by a Type 2 civilization, that is basically going to use that Dyson sphere as a means of collecting the energy associated with the output of the star and then using it to power their own civilization. So we can imagine all sorts of vast engineering projects such as these, but when we look out into the universe, we don't see any evidence of these structures. Well, maybe. A couple of years ago, an interesting case emerged from Kepler data. Kepler is a telescope that is used by NASA, for example, to observe the passage of planets passing in front of their stars. So, for example, this graph right here is an example of what is called a light curve. A light curve basically plots the brightness of the light that you're receiving with your telescope as a function of time. This is a typical light curve associated with what is called an eclipsing binary star system. Two stars that are in orbit around each other, they pass in front of each other along our line of sight. So because they eclipse one another, this then means that there is a corresponding dip in the brightness associated with those stars. So for example, when you see this large dip in brightness right here, this then simply means that the dimmer star is passing in front of the brighter star. When you see a dip like so that is of less value, this then means that the brighter star is passing in front of the dimming star. So if you, or the dimmer star. So if you have two stars in orbit around each other as an eclipsing binary system, you're going to see a regularity associated with this graph. Once again, this graph is called a light curve. At any rate, however, a couple of years ago, Kepler observed an interesting star that has a very unusual, to say the least, light curve associated with it. This is the light curve of that star, and if you take a look at this portion of the graph right here, it stretches literally over years. Okay, there is essentially no periodicity or no regularity associated with the dips in the brightness of this star, as we've seen over time. We have these unusual light curves associated with this individual star. Now, why would this be important? Well, it is feasible that what we're seeing here is the construction of a Dyson sphere around that star, and then therefore, as the construction of that Dyson sphere progresses, you would then see corresponding dips in the brightness of the star. And because the mass of the Dyson sphere would be distributed unevenly as you're constructing it, this would then lead to all sorts of irregularities in the dipness, if you will, or the dimness of the brightness of this star. Okay, now it is, however, much more conceivable, quite frankly, that this has a natural explanation. One natural explanation is that what we've actually witnessed here is the collision of two planets in orbit around that star, and then therefore the dust debris associated with the planets is beginning to obscure some of the light. Quite frankly, with this star, we really don't know exactly what is going on. Most people suspect, however, it has some sort of natural explanation, just as I described. Okay, and then there was this object here that passed through the solar system a couple of years ago. This object is named Oumuamua, and Oumuamua is the first asteroid or comet that we have ever seen that definitely has an interstellar origin. Basically, as it passed through the solar system, like so, it did so on a hyperbolic trajectory, which means that it came in from interstellar space, whipped around the sun, and then is on its way back to interstellar space. The speed of this object is greater than the escape velocity necessary for the entire solar system. So it basically came in from interstellar space, whipped around the sun, and then is starting to move out. And now the reason why this is important is because of a couple of things. Okay, first of all, notice the shape here of this artist's rendition of Oumuamua. It's extremely elongated. It is actually very difficult in nature to produce a shape such as this through natural processes. And then something else that was interesting about this object, after it whipped around the sun, after it passed through perihelion, quite mysteriously, it actually accelerated a little bit, and we're not quite sure why that is. Now, one possible explanation for the acceleration of this object would be is if this object was some sort of comet. As it whipped around the sun and got heated up, gases would be expelled off of that comet, and then the gases being expelled off of that comet would act as a sort of rocket thruster, if you will, thereby giving the object a little bit of a push. So we looked for that as this object was whipping around the sun. We looked for evidence that it was expelling gases in some manner, but we didn't see any evidence of that. As far as we can tell, it basically is a cold object. So what is the explanation for this? What is the explanation for this weird shape? What is the explanation for its acceleration as it passed through, or after it passed through perihelion? Another thing that's interesting about the object itself is that it actually is at rest with respect to the local neighborhood's reference frame. Now, when I say local neighborhood, I'm talking about the sun and the nearby stars as we all essentially orbit the center of the galaxy more or less together. Oumuamua is at rest with respect to that reference frame. So it's almost as if it's kind of like a buoy out in the ocean, and then ships are passing by that buoy, and we just happen to pass by. That is, one of those ships would be the sun. So there's all sorts of interesting coincidences here about this object Oumuamua. So exactly what is it? Well, it's been hypothesized that Oumuamua may actually be an artificial light sail. It's obviously very unlikely that it is, but it is a possibility. We'll probably never know the answer to this question as to exactly what this object was, because by this point, Oumuamua on its way out of the solar system is moving too quickly for us to be able to reasonably catch up with it with some sort of flyby mission. It would be more or less impossible to do that at this point. So then the main question about Oumuamua really becomes this: are there other objects out there like it? We've already seen some evidence of other objects from interstellar space passing through the solar system in the last year or so, but with those objects, they actually behave like normal comets. So remember what I mentioned earlier, as a comet whips around the sun, it gets heated up and gases get expelled off of that comet. We've seen that happen with a couple of other objects that have come in from interstellar space since observing Oumuamua. So Oumuamua, to this date, really remains a mystery. Most people tend to think that it's probably not an artificial light sail. There's probably some sort of simple physical explanation for its acceleration that has been worked on extensively over the last year or so. Pretty much everybody concludes, however, that it is definitely an unusual object, and it probably is of natural origin. Okay, and then lastly, what might be the future of humanity? We may be in control of our own evolutionary destiny as we perhaps approach what is called technological singularity. Perhaps a post-human intelligence would choose to no longer exist in the material world. Perhaps sometime in the future we might be able to digitize our consciousnesses and then live in some sort of virtual reality simulation. So if a civilization advances to that point, it quite frankly may actually not be worth all the energy expenditure to go out and colonize the galaxy. There might be a simple way to reach some sort of utopia, perhaps through some digital means. Okay, a lot of questions here to ponder as we conclude this screencast here covering the possibilities of life elsewhere in the universe.